Dwayne Das. Dwayne Das, please, Mr. Sir, come on stage. Please come up on stage. Okay. Mr. Dwayne Das' industry experience spans over 35 years. He started his career with Electrocraft in the year 1986, where he got the opportunity to work with big Indian and international artists like Lata Mangeshkar, Asha Bhosle, A.R. Rahman, and even international bands like Bryan Adams, Bon Jovi, to name a few. He has undergone training with popular speaker manufacturer companies like Acoustics and DNB Audio Technic. Today, Dwayne is the national head for Alpha Tech, where he gets the opportunity to not only design but redesign audio equipments to best fit the consumer needs. Dwayne believes in sharing his knowledge he has acquired over so many years, and we are very lucky to have him here with us today on the stage that he's sharing with Palm. I request you to please take the stage ahead. Thank you.
Check. That's what I do when I test my system normally, when I first put it on. Okay, so as you know, my name is Dwayne. I've spent about 35 years in live sound industry. And there's a lot that goes around in a big stage production, which very briefly, which takes us sometimes 5 days to set up, 10 days, sometimes a month to put everything all together. So what I'm going to do today is I'm going to get through the key aspects. It is not going to be elaborate because we don't have time for that. But yes, the key aspects. So now there is somebody who spoke earlier. He's my mentor. We worked together for 32 years. His name is Mr. Roger Drago. That's who I worked with for 32 years. Till I moved on to Alpha Tech. And it was difficult then those days because there were no computers, no nothing, but life moves on, and this is what I am going to be talking about now as to how we do stuff nowadays for the live arena. Doesn't seem to be moving. Okay. Okay, the first thing that we should be looking at for a big live production is the size of the ground, whether it's got balconies, whether it is how high are the walls, where do you want to aim to. So for that, we have prediction and simulation software. Now, every big company, every big speaker manufacturer has got its own software, prediction software. And you have to use that. I mean, it saves you such a lot of time. A little later, I'm going to show you a couple of slides as to what a good simulation can do and what a bad simulation can do. You want to basically get uniform coverage because you don't want people at the back saying, no, I can't hear, or I cannot feel the music. You don't want people in the front saying that it's too loud. You don't want, I hate it when people tell me that, you know, there's a sweet spot in the center. It's a very audiophile term, a sweet spot. This is something that we don't want to achieve. We don't want to have a sweet spot happening on our venue. We want everybody, and that's what every live sound engineer will try to do. He will try to achieve equal coverage over the frequency range right through the venue. So I'm basically going to show you, this is going to be an interactive thing, because if there are questions that you'll want to ask me as I'm speaking, you all can stop me and I will answer those questions. I will try and answer those questions. But I'm just going on with this and wait for you all to ask for questions, okay? Now, mapping. Now, this is a mapping of a very popular system software. As you can see, there are a lot of white spots. Means if you can look at the left, it's over 106 or 108 dB is what you're getting in the front. And as you go further down, it goes down to yellow and green. Now, this is a badly plotted system because you are not going to get uniform coverage. You're not going to let everybody in the venue get the same kind of feel like the guys in the middle, okay? And this is what it translates to when you simulate it. So you can see the hot spots right there right at the beginning, and then as it goes down, the red turns to yellow, yellow turns to green. So green goes down to 91 decibels. This is all A-weighted, okay? So this is what you want to avoid, and to avoid that, what do you need to do? You need to plan a little better. So you go there and you plot out, get a fewer boxes in the beginning, aim for lots more boxes at the back. So you can see I've got 1, 2, 3, 4 boxes really close to each other. So that makes the speakers on top really push energy at the back. Okay? And that is how you get your simulation to look like this. Okay? Now, as you can see, yes, there are hot spots in the front, but that is only the front fills, which you can very easily tone down. Couple of dB, 3 dB, and that's going to be, it'll be fine. And you can see, and at the end, it's always good to know what you have at the end of your venue. If you have a wall, you want to try and avoid reflections coming from that wall. You want to try as much as you can not to let too much of energy hit the wall, because the people in the end are going to hear direct sound and reflected sound. Sometimes the reflected sound is louder than the direct sound. There's a lot of cancellation, there's a phase problem, so you have to avoid that. So try and cut down your speakers from slapping on the back wall. Okay. Now, all this has been achieved. This is what you do at home. What you do at home is sit down. You have to find out the size of your venue. You have to find out if there is any walls around, any reflective surfaces, and program that accordingly. Put all the coordinates into your software, and it comes out with this. So then you know exactly what your angle straps are, at what height your speaker has to fly to achieve this, and so on and so forth. Okay, now, coming back, now you're done with your system. You're done with the system check. The guys who are rigging it will rig it. You've given them all the angles, all the coordinates to put up the system. Okay? And they will be doing that. So in the meantime, what do? You have to look at what the band needs, right? So the band needs stage monitors, side fills, miking, strong RF signal for IS. So let's start with stage monitors. A lot of bands now like to go with in-ear monitors, but a lot of bands also like to go with wedges because they have that interaction. They can hear the crowd. Another way of getting the crowd into their ears is putting 2 microphones up front and feeding it back into their ears. That can also give you a feel of the crowd and what the crowd is, if the crowd is talking to you, to the main singer or the guitarist or whoever it is, they get a little bit of feed coming back from the crowd. Side fills, some bands use and some bands don't. If the whole band is on in-ears, there's very little use for side fills. So going back to monitors, stage monitors and in-ears, if you have, for instance, if you have a drummer won't get enough of low end into his ears, so sometimes drummers use a sub. Then there's miking. Now that's my pet project, because I'm a big believer in using the right mic for every instrument. First and foremost, I like to go, like the way I do it is I go on stage. Lots of bands, I have actually sat down and tuned their drums, because for me, once your drums sound good and the bass locks in, that is, for rock bands I'm talking about, that is the foundation of the band. The guitars, keyboards, and vocals are all over that. So I will personally go and check the drum. If there's a tabla, I will go up to the tabla guy. I will hear his tabla. It's very, very, very important. How you place the mic for a tabla is so critical. Uh, Guitars, acoustic guitars. I prefer using a microphone for a guitar, for an acoustic guitar as compared to lineouts, because lineouts sound a little harsh. Again, placement of the mics. All these things you can learn. There is nothing that is not there now on the internet. We didn't have it. I had to figure it out for myself. I'm talking about 1986 when I started. And in those days, all that we had were SM57s, SM58s. Those were the best mics we had. And believe me, I used to use an SM58 on a kick drum. Today, people have got Beta 52, T6s, 901s, 902s, whatever. But we had SM58s, and we had to make do with what there was and try to make that kick drum sound like a kick drum, you know? Yeah, so miking for me is very important. What mic you choose, obviously for a kick drum, large diaphragm microphone. For a snare drum, any dynamic microphone I would prefer. The tendency, it's going towards using condenser mics now for everything, but that is not a solution. That could sometimes also be a problem, especially if you're using wedges as monitors. If the drummer wants the snare too loud, you have to be really careful about how you send that back to him. Coming back to monitors, monitors have to be wrung out. There's no monitor in the world which, when the company says this is a monitor preset, and it'll sound like a good monitor. There's no monitor in the world that can do that. Trust me, I've been through that. And again, there is no preset that you can use for a monitor. You think you use this preset with this graphic EQ and those parametric EQs on the monitor for a band, and you want to take the same thing as a engineer of the band and go to the next venue and strap it down on the same desk into the, it's 100%, if they're using the same monitors, it'll work. If they are not, you better go back to zero and re-EQ your monitors again, because that is something that is going to save us, especially if you're doing monitors for front of house. And I know a lot of people, a lot of bands, the big bands, yes, they will have a monitor engineer who's going to take care of that. But the smaller bands cannot afford to have a monitor desk, leave alone a monitor engineer. And that makes 90% of the bands that are traveling today in India. Okay? 10% may have a monitor engineer and a monitor desk. So when I travel, I insist, I give a set of monitors, and yes, I do make presets for different monitors, but only if those brands are there. If those brands are not there, then I have to go back, because that's a great starting point. Okay? Having a preset is a great starting point. But if I am going to go to a venue with a totally different monitor from the ones I've worked with, and there are hundreds of monitors and hundreds of models. So it's very difficult for you to say, no, I want only this and this alone. It's not going to work. You will get something. If you ask for a monitor, you will get a monitor. You say 12-inch or a 15-inch and a horn, you'll get that. But you may not get the brand of choice. Okay? So what happens then is that you have to start from scratch, because starting from scratch is a much, much better place, because you're going to be knocking off frequencies for the monitors which are not going to be causing you any problems, and knocking off that power from the monitor. For instance, say there's 250 hertz, which is bad on the other monitor, and this monitor can really handle it well, and there's more rejection from the mic to 250 hertz. You need it there. And EQ has to be used and not misused. I see people going with EQs with smiley faces, high frequency up. An equalizer is meant to cut more than boost, is what I believe. Because if you're going to be boosting frequencies on a monitor of repute, there's definitely a component broken there, or the speaker is damaged. There's not a speaker I know in a wedge kind of format that you have to use where you have to boost up the high frequencies. Okay? Another thing I notice about people when they're EQing is that they look at the EQ and they do an EQ. Arey yaar, ye theek nahi dikh raha yaar. Let's change it, you know. Arey, this is not looking good. Suppose you cut one frequency here, no, it's not looking good. It should look smooth. There's nothing called an EQ looking smooth. An EQ should sound smooth. And that is what everybody's got to know. Yeah. Knowing your frequencies if you're doing monitors. Knowing your frequencies. Very, very important. We had to learn it because we didn't have no RTAs when we started off. So you go around, give yourself a test. Today you get a lot of oscillators, signal generators, where you can actually, so it's basically 100, 250, 500, 1K, 2K, 5K. So once you know those frequencies, you know, you hear a feedback and you know which 3 or 4 faders you have to go through at the graphic EQ, okay? Because you can sit down and if you don't know your frequencies, you're pulling down everything, you don't know what you've pulled down, you know what you're pushing up, it all becomes a mess. So it's a very good exercise for people to actually sit, hear the frequencies, whistle the note, hear it, whistle it, copy it back, hum it, so you know this is 1K, this is 250 hertz, that's 500 hertz, this is 2.5K. So that makes it so much simpler. People are relying too much on machines today. Even the consoles that are coming out with, I mean, I was surprised to see one console about 8 years or 10 years ago which actually sets your gain for you. You ask the kick drum to kick, you press the knob down, and it actually sets the gain for you. I mean, where is gain structure gone? When are people going to be learning gain structure? If machines come like this, you're not going to learn anything, okay? So gain structure is the most important thing. So the machines are going to be controlling us now. Machines are going to be telling us how to mix. Anyway. So coming back to miking, yes, miking is, as I said, plays a very integral part in my thing. I like to have, for dynamic instruments, normally dynamic mics. That's my rule of thumb, as much as anybody can tell me anything else. Yes, I tend to use sometimes. I got a few favorites, which I know how they work and I know what they can do. So exceptions are, yes, I do put in condenser mics as well. Okay, the next thing that we are looking at is strong RF signal for wireless mics and IEMs on stage. Now, we in our country, we do not have too many RF engineers, at least, I mean, at one time. Now, I guess a few have been coming up as, just experience, not really trained, but experience, yes, and experience does a lot for a person. I have done an event, a huge event, which I'll show you pictures of with simulations later on in this in my chat, where there were 168 RF frequencies used. It was way beyond my pay grade. I actually told the producers to call an RF engineer from whichever part of the world and do it for me because I could not look at audio and RF simultaneously. So, yeah, the guy came and I thought he did a fabulous job. So, again, you have got software now to scan and look at what frequencies are being used and what frequencies are spare for you. We don't really have any control over radio frequency in this country. I mean, if you go to the West, you go to the US or you go to the UK, there is only this amount of frequencies allocated to you, and you're literally within 120 megahertz. You have to be able to put in all your microphones and all your wireless components there. Yeah. So this wireless is, and it's commonly used. I mean, there's no show well, I'm talking on a wired mic, so I think that's cool. There's no gig that happens anywhere that does not have at least one wireless mic. So wireless, strong RF signal for wireless mics and IM on stage. So what do you have to do? Have to make sure that your antennas are placed well. You have to make sure that connectivity, your connectors are nice and tight. They are not loose. The BNC connectors tends to be, because it's like a spring action. If somebody turns it around, so as a rule, I normally tape it. Because if you lose one antenna, you're losing 10 microphones if you're using 10 RF microphones on stage. Okay, so that's really, really important. Not happening. Next. Okay. Now, when you're doing a huge production, what are your concerns? Your concerns is general safety. When I'm saying general safety, it's general safety as far as your crew, people working around you, the band, and the audience. Those are your key factors. Starting with when you come to the ground, scaffolding. I've seen so many scaffoldings go down. Not just, it's the problem there is not just the scaffolding going down. If there's somebody standing close to it in the vicinity of 36 or 40 feet, whichever way it's falling down, it'll be fatal. Okay? So there are lots of things that you have to do to make that scaffolding secure. Number one, when the scaffolding goes up, make sure that it's got enough of bracing. If you have a doubt, put another scaffolding up to 8 or 16 feet height behind the scaffolding so it makes it more steady, more footprint. Never ever let any production tell you that there's an ad and we want to put banners on the scaffolding. Because in event of a storm or wind, if the banners are there, your scaffolding's 100% falling down. 100%, without a doubt. Guy wiring is an excellent idea. Guy wiring the scaffolding down. So that is the safety you can take. Never, if it's a line array, never drop that line array to the ground. Don't try and save your speakers, because if it's on the ground, it's going to act like a sail. Nothing, the wind is not going to move it. When it gives, the wind is actually letting the wind go past. When it's standing down on the ground with no gap between the boxes, it is acting as a big wall. And wind pressure wind force is something that you don't want to mess with. So never ever if you want to don't put plastic, don't put anything. Line arrays are meant to be out there in rain. They will drip down, and because the show is not going to happen immediately. The show, if it's raining, lots of things will go down, lights will go down, crowd will be running around helter-skelter. So wait for it to drip dry and go ahead with your show. It will happen. Cover your amplifiers. That's what I would think. The second thing is electrical, which not many people give a big deal about. Electricity. Generator aega, dega humko par, chala. But how do you distribute 3 phases of a generator? What do you do? If it's a 125 kVA, what is the generator actually giving you in kilowatts? It is a 125 kVA generator will give you with difficulty 80 kilowatts. Difficulty. Okay, if it's a damn good generator, brand new amateur, 80 kilowatts. Okay. Now, how do you distribute it? You cannot have everything going on one phase and the second and third phase being unloaded, because then that is going to cause a return coming back on the neutral, which you don't want. Again, a generator is on wheels, on rubber wheels. So Nothing is grounded over there. Very importantly, neutral has to be grounded. To get zero potential, neutral has to be grounded. Okay? You can have separate earth for everything else, but the neutral has to be grounded because you get zero potential from there. If there's any leakage going, it goes down to ground. You are getting, for a big production, what I would do, dig a huge pit, put in coal, salt, mud with a huge copper plate and get a 100 ampere cable to ground. And everybody in the production, be it audio, video, lights, whoever, is going through that ground. Because we do not want a ground loop happening. It's worse for you. So as long as everybody knows what they're doing, and brick productions, normally everybody knows what they're doing. So we will give a tap for ground, and a 100 ampere cable can handle 100 amperes. So that's the whole reason why we use such thick cable. And it's a misconception saying earthing hai na, it's not carrying any current. But when it has to carry current, it shouldn't burn. If for whatever reason there's a huge surge and huge leakage going down to earth, that cable has to be able to take the amount of load that is coming in and put it into the ground. Because if for whatever reason it breaks, it burns and breaks, the guy on stage, guitars, microphones, bass guitar, whatever, is going to get electrocuted. Because he's got this huge current going through. Okay, because there is no ground, nothing is going to ground, it's going to come into him. Okay? So general safety, electricity, mechanical, okay. Mechanical, I'm talking about the trussing that you use sometimes over your scaffolding to hang your speakers. I have seen people using I-beams. Horrible. I mean, why would somebody take an I-beam and put it on top? But some people do it. But even when you put I-beams, I mean, you should know how an I-beam has to be seated. It cannot be seated the other way around with like an H-beam. I've actually seen a situation where somebody has hung a huge array on an I-beam which is placed badly, and the I-beam actually gave. He was damn lucky that it didn't give. It didn't break. It just bent.